talk, we're going to go through the things that allow you to improve the performance and security of your MySQL installation. Now, the performance and security of your MySQL installation is obviously a very big thing. It doesn't matter if you're a MySQL DBA or if you're a developer, MySQL security is obviously a very, very important topic for everyone who deals with databases in any kind of scenario. Before we actually begin, I would like to introduce myself. I have a background in MySQL in security because I was building one of the biggest and fastest data breach empires, data breach search engines, and data breach directories in the world, which means that I archive data breaches and I allow people to search through them for them to realize the extent of their exposure and to protect themselves from identity theft attacks. I usually blog at multiple places. I run two of my own blogs. I blog at lukasvileikis.com. I blog at Breach Directory blog, which is primarily dedicated to data breach analysis, but I also blog about MySQL security and other stuff. I also blog at other places, such as the Computer Emergency Response Team, right? I work with the cyber police to catch cyber criminals, and I also blog at Severalnines. I do marketing at Severalnines. I produce blogs, as I already said. I produce some webinars. I talk at conferences. I spoke at multiple local conferences. I spoke at BuildStuff, which was the biggest software development event in the Baltics. I spoke at DevTalks. You can see me hanging around in TEDx, and you can obviously now see me talking at Percona Live. So the agenda of this talk would be we are going to go through a couple of security things that allow you to improve the security and performance of your MySQL installations, obviously. So we're going to go through the basics of MySQL security, then we're going to go through MySQL access control, we're going to go through accounts and their security, account locking and unlocking, privileges and roles, and also password management and password security in MySQL, which is obviously very important. Then we're going to go through a couple of things that MySQL offers plugin-wise, how to improve MySQL security with plugins, right? And then we are going to go through MySQL backups, because if you use MySQL, if you use any kind of database, chances are that you're kind of backing up your data, right? We are going to go through MySQL backup security. And finally, we are going to go through how the MySQL security decisions impact performance. So we are going to look at security from the performance standpoint as well. And then we are going to kind of summarize everything that we have talked about. So to begin with, we have some key considerations. We have some basics, right, that are related to MySQL. And as far as MySQL is concerned, you will probably very frequently see MySQL Secure Installation or MariaDB Secure Installation mentioned. And what it is it's essentially a shell script that is available on Unix systems, and it enables you to improve the security of your MariaDB or MySQL installation. MySQL Secure Installation is a symlink to MariaDB Secure Installation. It can be used on both platforms, MySQL and MariaDB. You can set a password for root accounts, you can remove root accounts that are accessible from outside the local host, you can remove anonymous user accounts, and you can remove the test database, which by default can be accessed by anonymous users. You also have some security plugins that MySQL offers. We're going to go through that in a while. So you have some general factors. For example, you should not allow anybody access to your MySQL instance. That is, your instance should only be accessed by the people that absolutely need to access that. And if your instance is also accessed by, for example, PHP scripts or something else, you should probably take care of, for example, PDA or something else to prevent SQL injection attacks, to prevent cross-site scripting attacks, and so on and so forth. And obviously, as far as MySQL is related and as far as web applications are related in general, you ought to always use strong passwords. Always use. Do not run root without a password, for example. It's a very bad idea, right? Do not run root with a weak password. Utilize strong passwords, and also back up your data, right? If you're using MySQL, or if you're using Oracle or Sybase or MariaDB or Percona server, it doesn't really matter, you should probably back up your data. This is not only limited to MySQL. This can be said about just about any information system that deals with data at some point. And as far as MySQL is related, you will probably hear people talking about MySQL access control, first of all, right? MySQL access control is closely related to accounts. It is very, very, very closely related to accounts. For example, you should avoid giving accounts access to the user table, because from MySQL's point of view, the encrypted password is the real password, so you should never give anyone access to it. In particular, what I mean by this, again, avoid giving accounts access to the user table in the MySQL system database, and only grant necessary privileges. For example, you need to avoid grant all statements if you do not absolutely need it, and if you are not absolutely sure what it does. All allows complete access to a specific database, and you can obviously make sure that you use security through obscurity if you want to. For example, you can consider renaming the root account. If the attacker knows your password but does not know what the root account name is because it's renamed, your database and your web application probably can be saved. Now, MySQL has this thing called MySQL account locking and unlocking, which we are going to be covering now. So basically, MySQL supports locking and unlocking of user accounts using the account lock and account unlock clauses for the create user and alter user statements. If an account is locked, you will see access denied for user account name at hostname. Account is locked. That means the account is locked. If you omit the account lock clause, the create user statement creates a new user in an unlocked state by default. If you use the, for example, alter user, then your user, and the account lock statement, you can lock an existing user account. For example, if you use alter user account name identified by password and then account lock, your account will be locked. You can also display the number of attempts to log into locked accounts by using, for example, show global status like and then locked connects. You can also unlock your accounts if they're locked, obviously, by using alter user, then if exists, then your account name, and then your account unlock. So basically your query looks like this: alter user, if exists, account name, and then account unlock. And obviously, as far as MySQL is related, as far as MySQL security is concerned, right, you also have such things as privileges and roles. Now, privileges, obviously, as it was already said, you should avoid granting unnecessary privileges to any kinds of users in MySQL. But we are going to be talking about the load data in file right now. The load data in file, or load data local in file, however you want to call it, it obviously has its benefits. For example, if you want to load data into MySQL server, it can be very, very, very useful. But you must not forget that the file privilege, it can also be dangerous. For example, load data and into out file, they can be used to craft evil files, for example, in SQL injection. And you also have such parameter called local in file, which controls the server-side local capability. Depending on the local in file setting, the server refuses or permits local data loading by clients that request it. So if you want to improve your MySQL security in that way, you can also do that. By default, local in file is disabled. You can explicitly cause the server to refuse or permit load data local statements regardless of how client programs and libraries are configured at build time or runtime by starting MySQL D with local in file disabled or enabled. With that being said, local in file, of course, it can also be set at runtime, so do not worry if you did not set it initially. Obviously, as MySQL is concerned, and as far as any database that deals with web applications or anything else is concerned, you have passwords, right? Passwords are obviously a very, very, very big part in MySQL as well. You have, for example, password expiration, you have password reuse restrictions, you have password verification, you have password strength assessments, you have random password generation. All of those things are provided to you by MySQL. For example, password failure tracking enables temporary account locking after too many consecutive incorrect password login failures. You can also utilize periodic password changes. For example, if you want your passwords to be changed every 3 months, you can use a variable called default password lifetime. For example, if you set this to 90 in my.cnf, your accounts will be required to reset their passwords every 90 days. So if you put default password lifetime equal to 90 in MyCNF, you will be fine. You can also disallow an account from accessing a database, that is lock out an account from accessing a database, which can be very useful if you know that an account is constantly trying to access a database and it should not be accessing it in the first place. Now, as far as MySQL security is concerned as well, you have MySQL security plugins, right? You have MySQL security plugins, and these can be split into kind of three categories, right? You have authentication and connection control plugins, you have the password validation plugin, and you have the audit and firewall plugin. The password validation plugin, it serves to simply test passwords and improve their security. The plugin basically checks the password against a password policy and rejects it if it is weak for certain statements that include create user, alter user, grant, and set password statements. Obviously, you have the password validation plugin, which helps you to make sure that your passwords are valid. You have authentication and connection control plugins, as it was already said, to basically connect who connects to your connects to your MySQL instances and who authenticates with your MySQL instances. As far as MySQL is concerned, backing up your data is obviously very important. If you do not back up your data, you should do that immediately, because if anything can go wrong, it will go wrong, right? If you have backups, it will probably be much easier to recover from a data outage, from a power outage, from a data corruption or something. So as far as backup security is concerned, you can encrypt your backups. For example, if your backups are not encrypted, you can encrypt them, or you can also utilize MySQL dump secure, which essentially is a POSIX compliant wrapper script for MySQL dump with encryption capabilities and strong security in mind. According to MySQL dump secure, the tool is like MySQL dump, but on steroids. So that's basically it for MySQL dump secure. Now you should probably also avoid putting your password in the MyCNF file, because avoiding the password, putting the password in the console and using my.cnf instead allows you to make your password invisible to system status programs, such as basically PS that can be run in Linux. So basically your password cannot be observed by system status programs this way. And also, as far as MySQL security is concerned, you also have to keep in mind some performance considerations that are related to MySQL, right? These are not only related to MySQL. These can also be useful for example, Percona server for MySQL, or for MariaDB, or for any other flavors, right? Obviously, we're not going to be talking about improving the performance of every engine that exists, because there's a lot. For example, you have MySAM, you have CSV, you have Blackhole, you have InnoDB, etc., etc. But we're going to be looking at one of the most important engines and most widely used engines in MySQL. That would be InnoDB. So with InnoDB, you have certain parameters. You have the InnoDB data file path, which basically depicts the file where data from InnoDB tables will be stored. By default, the file is ibdata1, and by default, its size is 12 megabytes. And it extends automatically, as you can see in this case. You can also increase the size of this file, but bear in mind that basically if you have a lot of data in InnoDB and you delete this file, and you delete the log files, they will be recreated the next time you restart MySQL, but then data from your InnoDB tables will be gone. Basically, there are workarounds to work around this issue, but for the time being, we're not going to go into them as deeply. You can check the Severalnines blog, you can check my own blog, I talk about this pretty frequently. You also have a buffer pool size. The buffer pool size is basically can be called one of the most important parameters as far as InnoDB and MySQL is concerned, because what it is, it's a memory buffer that InnoDB uses to hash data and indexes of its tables. The larger for example, the InnoDB log file size is, the less recovery time you need in case of a crash. And these two parameters, they're kind of related. For example, if you have 16 gigabytes of RAM on your server, you might want to set the InnoDB buffer pool size to 4 gigabytes or even more, because it's recommended to set this thing on like 60 to 80% of available RAM. Obviously, also keep in mind that you also have to make space for other processes that might run in the operating system. If you set the InnoDB buffer pool size to 4 gigabytes, it is safe to set the InnoDB log file size to, for example, 1 gigabyte up to a quarter of the buffer pool size. That would be a very nice thing, and it would improve your performance of your MySQL InnoDB engines. Now you also have the InnoDB log buffer size, which is used to write the log files on disk, which is pretty important as well. And what's very important as well is the InnoDB flush log at transaction commit parameter. This parameter, it basically has three values. It has 0, it has a value of 1, and it also has a value of 2. If you set the value to 0 or 2, you get a very fast write speed, but then MySQL can lose up to 1 second's worth of transactions. The default value, as you can see in this example, is 1, which helps keep InnoDB ACID compliant. ACID is atomicity, consistency, isolation, and durability, and it's basically a set of database properties that are used to kind of ensure that your database stays in shape whatever happens. For example, if you have a query that is running and your electricity goes out and your database is ACID compliant, and if you're using InnoDB, it's ACID compliant by default, your database will not be corrupted. For example, on the other hand, if you use MySAM, for example, it's not ACID compliant, so your data will probably be corrupted. InnoDB lock wait timeout is the amount of time in seconds an InnoDB transaction waits for a row lock before giving up. And the InnoDB flush method is also one of the most important parameters that you should take care of when dealing with InnoDB and when dealing with MySQL in general. This flush method, it defines the method used to flush data to InnoDB data files and log files, which can affect I/O throughput. It has three values. It has a value of normal, which is the default value in Windows. It also has the value ODirect and ODsync. And the differences between those three values is that normal is only available on Windows. For example, ODsync is faster than ODirect because it performs writes without any kind of verification, while ODirect is paranoid, but it's more data consistent. ODsync is faster than ODirect, but data may or may not be consistent due to latency or an outright crash. ODirect is more stable and data consistent than ODsync, but ODirect is naturally slower. So if you want data consistency, you should probably consider using ODirect, right? If you, for example, if you want some faster transactions, you should probably consider using ODsync. But then, as it was already stated, then data may or may not be consistent due to latency or an outright crash. Now, MySQL, it's a very complex beast, right? As you probably already know. MySQL also can run big data. For example, I run breach directory, as I already said, and it's a data breach directory and a data breach search engine. I house more than 10 billion rows in MySQL, and my queries are still performant. Why is that? Well, it's like this because my MySQL instances are optimized. My InnoDB instances are optimized to the maximum, and it just shows that you can optimize your MySQL instances to such a level that you can even run big data on MySQL. For example, one of the biggest of my tables has more than 3 billion records. In total, it has 3,009,217,743 records. That's for one table. Imagine if you have like 100 or 1,000 tables and your queries are still performant. This is what we're talking about. This is how MySQL and InnoDB can be really optimized for performance and for security at the same time. So if you follow the advice that I gave you, you can be pretty sure that your MySQL instances will be secure and performant at the same time. So basically, to summarize this, you should take care of MySQL security basics, right? You should use strong passwords, you should not give unnecessary privileges, and you should also securely take and securely store your backups. Now, you should also probably consider looking into MySQL security plugins. For example, you have the authentication and connector control plugins, you have the password validation plugin, as it was already said, and you have the audit and firewall plugins. And you should also not neglect performance. If you use InnoDB, if you use MySQL, you should probably use InnoDB, right? It's the default engine. And you should also probably make this ACID compliant if you want real reliability, right? So I hope this presentation has helped you, and thank you. I hope this presentation has widened your horizons in MySQL space and you have learned something useful from it. Secure your MySQL instances, but while doing that, also do not forget security issues and performance issues you might encounter on the way, and think of them beforehand. I wish the best of luck to you in the MySQL space and in your MySQL journey, and I thank you very much.